welcome back. Hope you are doing good. This is Mahesh. In this video, we will continue on the examples of computing time complexity. So we were computing the time complexity of decreasing functions. Basically, they are the recursive ones. So we will continue on that. So till now, we have seen few examples which look something like Tn equal to T of n minus 1 plus 1 and Tn equal to T of n minus 1 plus n. So what these examples say, so at each iteration there will be one unit of work happening in this equation, then the problem is getting reduced to n minus 1. Initially it will be n, then it gets reduced to n minus 1. So that is how we can interpret this particular expression. And if we see this expression, at each iteration there is n amount of work that is happening at each iteration, and the problem is getting reduced by 1, that is, it is going to be f of n minus 1. So now there is a little bit change. So let us see example something like Tn equal to 2 into T of n minus 1 plus 1. So here what was happening, at each iteration the problem was calling itself by reducing the input by 1, but here what is happening, the problem is getting reduced by 1, but it is being called twice. So how to solve such equations? So we will follow the same procedure. One is back substitution and another one is recursive tree method. So we will start with back substitution. So let's call this one as first equation. Okay. So now for this computation we need T of n minus 1. So let us try to compute T of n minus 1. How to do that? We will replace wherever n is there with n minus 1. So it will be 2 into 2t of n minus 1 minus 1 plus 1. So that is 2t of n minus 2 plus 1. So this is our equation 2. Now what we will do, we will substitute this particular equation 2 in 1. So our Tn will be 2. This is our T of n minus 1. So that will be T of 2 T of n minus 2 plus 1. Okay. Then plus 1. Okay. Now if we simplify this, 2 into 2, 2 square, T of n minus 2 plus 2 plus 1. Okay. Let's call this as 3. Now again we need T of n minus 2. So that will be 2 into T of n minus 3 plus 1. So how? We just substituted n minus 2 in place of n, so that we got n minus 3 plus 1 here. So we will call this as fourth. Let's substitute this in equation 3. So our T of n will be 2 square, and we will replace this with this particular equation. So it will be 2t n minus 3 plus 1, okay, then plus 2 plus 1. Now if we simplify this, it becomes 2 cube t into n minus 3 plus 2 square plus 2 plus 1. Okay. So this one we can write it as 2 to the power 1. This one 2 to the power 0 we can write. Okay. Now if you see how we can generalize this equation, it becomes 2 to the power 3 t n minus 3 plus 2 to the power 2 plus 2 to the power 1 plus 2 to the power 0. So here it is 3, here it is 3, then here 2, 1, 0, it gets reduced. So how we can generalize? T of n equal to 2 to the power k, okay, t into n minus k, okay, here 2 to the power, since 1 less than this, so since we are using k here, it becomes k minus 1 plus 2 to the power k minus 2 and so on till 2 to the power 2, 2 to the power 1, 2 to the power 0. So this is how we can generalize. Okay. Now, if you see the equation, we have t n minus k. So we know t of 1 equal to 1. Correct, right? So I think we have not written that here, but this equation will be for n greater than 1 and it is equal to 1 for n equal to 1. So that's the generalized recurrence relation. So now for that, if we want to do this, then our n minus k should be equal to 1. So if that is the case, what is k? So we will send this here and 1 here. So that becomes n minus 1. So this is our k value. Now let's substitute that k value here. Okay, so then what happens? This will be 2 to the power k will be n minus 1, t of k will be, so n minus k will be n minus 1 plus 2 to the power, this is k minus 1, k will be n minus 1, so it becomes n minus 1 minus 1 plus 2 to the power n minus 1 minus 2 and so on till 2 to the power 2, 2 to the power 1, 2 to the power 0. Okay. Now this gets cancelled and this becomes t of 1. So 2 n minus 1 t of 1 plus 2 to the power n minus 2 plus 2 to the power n minus 3 and so on till 2 to the power 2, 2 to the power 1, 2 to the power 0. Correct, right? Now this is 1. So it will be 2 to the power n minus 1 plus 2 to the power n minus 2 and so on 2 to the power 1 plus 2 to the power 0. If you see, this is nothing but, I'll write it in a reverse order, 1 plus 2 plus 2 to the power 2 plus 2 to the power 3 and so on up to 2 to the power n minus 1. So this becomes a geometric equation, so geometric progression equation. So if that is the case, how to find sum of n terms? So sum of n terms, Sn equal to a into r to the power n minus 1 divided by r minus 1. So our a will be the initial term, which is 1, and our r will be 2 here because every time it is getting multiplied with 2. So our r will be 2 and we got r, we got a. So now what we can do, we can write this t of n. So we can simplify this. A will be 1 into r is 2 to the power n. So basically here it is starting from 0 and it is ending at n minus 1. So it means there are basically n terms. So I am taking it as n minus 1 divided by 2 minus 1. So this equation becomes Tn equal to 2 to the power n minus 1. So if we ignore this constant term, it becomes of order 2 to the power n. So this is how we compute the time complexity for the equation. So now this is using the back substitution method. Now let us try to use the recursive tree method to find the same order of the recursive function. So we know our function Tn is equal to 2t of n minus 1 plus 1 for n greater than 1 and 1 for n equal to 1 here. Okay, so this is our equation. So now if we want to write the recursive tree method, initially there will be our function fn. Then what it will do, it will does one unit of work, which is this, and it will call 2 times t of n minus 1. So this is our f of n minus 1. Then this is our f of n minus 1. Correct, right? So this is how our two sub equations will be called. Now what happens, again f of n minus 1, it will do 1 unit of work, then it will call f of n minus 2, then again one more f of n minus 2 call. Correct, right? Now, if that is the case, the same thing will be called here as well. So, this is how the call will be made. There will be one unit of work, then two functions, f of n minus 2, f of n minus 2, like this. This is in the second iteration. Now, in the third iteration, again what happens? Again one unit of work, again one f of n minus 3 call, again one f of n minus 3 call. This happens in all the functions. Correct, right? This happens in all the functions. So, how long it will continue? So, it will continue until unless this f of n, this function basically f of n minus something becomes f of 1, f of 1. So, it means it started at n, then it ended at 1. So, basically there are almost n number of, the n is the height of this particular recursive tree. Now, how to calculate the work done? So, at this particular step, basically there is one unit of work that happened, and at the second step, basically that is 2 unit of work. This is 1 and this is 1. So, it is going to be 2 unit of work. Next, in the third iteration, so here 1 unit, here 1 unit, here 1 unit, here 1 unit. So, basically 4 unit of work is done. Now, if you see in the next iteration, it is going to be 8, correct, right? And it will continue. So, how we can write this one? We can write it as 2 square, this one 2 cube, and so on, till when? Till some point 2 to the power k. So, if that is the case, then we will have to sum up to get the total work done. So, 1 plus 2 plus 2 square plus 2 cube and so on till 2 to the power k. But what is 2 to the power k here? It is nothing but, since there are n iterations, it will be somewhere near to n. So, I will take it as 2 to the power n. Again we got the GP. So, we will apply the same formula. So, A will be 2, R will be, A will be 1, sorry, the initial term, R will be 2. So, sum of n numbers will be A into R to the power n minus 1 divided by R minus 1. So, this is 1 into 2 to the power n minus 1 divided by 2 minus 1. So, it is somewhere equal to 2 to the power n minus 1, correct, right? So, if we ignore this constant term and take this particular equation, so it becomes of order 2 to the power n. So, this is how we compute the order of this particular recursive equation using recursive tree method. So, that's it for this video. Hope you like the content. If that is the case, consider subscribing to my channel and also share this video with your friends. Thanks for watching.